Beginning our review video for section 4.4, that's chapter 4, section 4. And of course, always we start with the learning target for the day. So the learning target today is to identify proportional and non-proportional linear relationships by finding a constant rate of change. A little bit about some new vocabulary words here. We're going to learn a new vocabulary word called linear relationship, and we're going to learn a new word called constant rate of change. Well, here are those definitions. A linear relationship is a relationship that has a straight line graph. We'll practice with that. And a constant rate of change is the rate of change in a linear relationship. So if it is a straight line, then it has a constant rate of change. Let's jump right in and do one here. Babysitting. The amount a babysitter charges is shown. The relationship between the number of hours and the amount is the relationship between the number of hours and the amount charged linear? If so, find the constant rate of change. If not, explain your answer. Well, first of all, I want to make sure that this is a constant change. That change there is 1. That change is 1. That change is 1, so it looks pretty constant. If I look at this side over here, the change from 10 to 18 is 8. 18 to 26 is 8. 26 to 34 is 8. So it is a constant rate of change. It means the babysitter earns $8 per hour is the rate of change, the linear rate of change. Please do this problem on your own. Come back and check the video to see if you're correct at the end. You can pause the video and then come back. Well, the number of hours here, 1 hour, 1 hour, 1 hour. 12 to 19 is $7. 19 to 26 is $7. 26 to 33 is $7. So this babysitter earns $7 per hour worked. It is a constant rate of change, and its rate of change is $7 per hour. Travel. Find the constant rate of change for the hours traveled and the miles traveled. Interpret its meaning. Well, on this one right here, I can pick any point that I want to on the graph. Any point I'm going to happen to pick from 2 hours to 4 hours, and I'm going to calculate my rate of change. Well, if I look at it, the change here was from 120, or from 60 to 120. So 120 miles at the end minus 60 miles at the beginning. So that's my rate of change. And the rate of change here was, of course, from 4 hours back to 2 hours for a total of 2 hours. So 160 minus 60 is 60 miles change in 2 hours time. So the rate of change is 30 miles per hour. And if I checked any point on the graph, for example, right here to here, I'd find the same thing. I'll do that. I'll say that 240 miles minus, so that's from here back to 180. So 240 minus 180, and that also was from 8 hours back to 6 hours. So the change was 2 hours. 240 would, minus 80 would be 60 miles in 2 hours. So the constant rate of change is 60 miles per 2 hours, or 30 miles per hour. And it is constant, and I could have told that by just looking at the flat line of the flat graph, the straight line graph. Please do that for this problem. Find the constant rate of change for the hours traveled and the miles traveled. Interpret its meaning. Well, I'm going to look at from the 2-hour timeline to the 3-hour timeline. All right, so 3 hours minus 2 hours to find the amount of change there. Of course, that's going to be 1 hour. And they went from 50 miles to 75 miles, so 75 minus 50 is 25 miles per hour. It is constant because it is a straight line graph. When you're talking about taxis, it says use the graph to determine if there is a proportional linear relationship between the miles driven and the charge for a ride. Explain your answer. Well, I'm going to go say from 5 miles driven cost me $8 to 10 miles driven costs $12. So I'm going to say 12 minus 8 shows a change of $4. And the distance driven was from 5 miles to 10 miles. So 10 minus 5 is 5 miles. $4 per 5 miles. If I look at that, it is a constant rate of change because it's a straight line. However, it is not proportional because if I checked ratios all the way along, I would find that this one is different. That ratio is different than the rest. Use the graph to determine if there is a proportional linear relationship between the number of movies rented and the total cost. Explain your reasoning. Well, I'm going to say if I rent one movie, it costs $2. If I rent 2 movies, it costs $4. If I rent 3 movies, it costs $6. So I'm going to do the rate of change between those two. I'm going to say from 3 movies, from 2 movies to 3 movies, I got 1 extra movie. And it cost me it cost $4 and then up to $6, so it was 2. So that is $2 for 1 movie, 2-to-1 ratio, $2 to 1 movie. And it is a constant ratio, and it is a constant proportionality. So here's our summary of information. 2 quantities, A and B, have a proportional linear relationship if they have a constant ratio, B over A, and their rate of change is constant. It takes both of those things to have a proportional linear relationship.